Hello and welcome back. I'm Benjamin Williams, and today we're still within the infrastructure section of Boson NetSim. We're moving on from Spanning Tree, which is a layer 2 protocol. We're moving on up to a layer 3 protocol. Today we're going to be configuring single area OSPF. So our objective for this lab, it says configure the network to use open shortest path first, OSPF, for a single area. All OSPF routers will be in area 0. So we can see our lab topology, and right here in the lab topology, it says the topology diagram below represents the net map in the simulator. Configure the devices in pod 1. Pod 2 is already being configured upon the initial loading of the lab. So we're just going to be configuring the devices, these 3 routers over here in pod 1. So we know we're doing open shortest path first, or OSPF. So like I said, it is a layer 3 protocol. We're going to be using area 0, which is the backbone area, as we can see down here in a topology diagram. Since all of these routers will be in area 0, they will all have the same LSDB, or link state database. Basically, as we know, OSPF is a link state routing protocol. So all of these routers will have the same database and same map of the whole topology. They will understand this whole topology right here, and they will use the Dijkstra algorithm to get to the, whenever they're trying to get to a network, the Dijkstra algorithm will calculate the shortest path to get to the specified network that they're trying to get to, and then it will forward the information from there. Like I said, it is a link state database routing protocol, so we know that that is an interior gateway protocol, or used within an autonomous system or within a organization. So let's go ahead and get into the commands and descriptions. I've already read through those. And let me just talk a little bit more about the topology. As we can see, we have an Ethernet. Well, first we can see that P1R1 and P2R1 are connected, it looks like, by an Ethernet connection. We have this connection, which is a point-to-point, a serial connection. And then we have P1R2, which is connected up to P1R3 through this switch connection right here. And that was using an Ethernet connection as well. So we've already read through all of the commands in the description. So we're going to do our regular. We're going to keep our lab topology up here in the top left. We're going to be doing all of our reading. Let me scroll down to the reading, the lab task right here in the top right. And we're going to be doing all of our configurations down here at the bottom. Let me refresh, because it's not pulling up my CLI commands as I hit enter. So let me hit continue. Come on, there we go. Go right here. And we're good to go now. So let's go ahead and get into task 1 of our lab task. It says enable OSPF within pod 1. So it says configure OSPF on P1R1, P1R2, and P1R3 using a process ID of 1. All interfaces, including loopback, should be placed in area 0. So let's go ahead and do that. Let's go ahead and go to P1R1. We're hopping straight into the configuration, which I like. Let's do an enable. Let's do a configure terminal. Let's do an router OSPF 1 for process ID of 1 to go into OSPF configuration mode. And let's start out with this fast Ethernet connection down here. So let's configure a network of 10.100.100.0. Let's do a wildcard mask of 0.0.0.255, because we're losing a /24 network mask. And let's do area 0 to place it in the backbone area. Enter. Perfect. All right. Now let's go ahead and do the loopback interface and also the serial 00 interface. We can really do those with one command. We can just do it for the 192.168.1.0 network, and it should work. So let's do a network of 192.168.1.0, and we can do an 0.0.0.255, and let's do an area of 0. Perfect. All right, so we have that network configured. So let's go to And that included the loopback 0 interface and also the serial 00 interface. So let me just make sure, because this has a /28. Let me make sure that it wants me to just do the, yeah, so it wants me to do a /24. I just wanted to make sure. Okay, let's go to P1R2 and P1R3. Okay, let's go to P1R2 first. Let's do an enable. Let's do a configure terminal. Let's do a router, OSPF 1. Let's do a network of, we can configure all of these interfaces. We have the serial 00, the loopback 0, and the fast Ethernet connection. We can enable all of those interfaces to participate in OSPF by doing a network of 192.168.1.0.0.0.0.255. Let's do an area of 0. And over here on P1R1, I forgot to mention, we seen that our neighbor adjacency came up right here with the P2R1 router right here. We can see that it went from loading to full. So that's what we want to see. We want to have full connectivity over there. We also just seen on P1R2, we have this adjacency that just came up with P1R1 right here. So we can see that it went from the loading to full. So that's what we want. So let's go over to P1R3 now. Let's do an enable. Let's do a configure terminal. Let's do a router, OSPF 1. Let's do a network of 192.168.1.0.0.0.0. So that's 255, area 0. Perfect. All right. So we have configured OSPF on all of these routers. Let me just make sure my configuration is like it wants in Boson, which it is. So we just did all of these configurations over here. So that's perfect. All right. And I just wanted to do this drop down because if I didn't do the right mask, Boson would basically say that my configuration is incorrect. Because right here, is saying that we should do a /24 mask. As we can see, it says 0.0.0.255, which stands for a /24. But up here in our configuration, I'm not sure if you guys can see this. Let me zoom in. If I can zoom in, yeah. This is saying a /28. So that shouldn't be 0.0.0.244. It should be, I think it should be 0.0.0.128 if I'm not mistaken, but I had to do the binary and math to get that exact answer. I don't know that off the top of my head. But right here it says, do two routers require the same process ID in order for a neighbor relationship to be established? And no, the process ID is locally significant. So no, they do not have to have the same OSPF process ID to be neighbors. So let's see what it says. It says no two routers do not require OSPF process ID. Well, do not require the same OSPF process ID in order to be neighbors. Okay. It says right here on P1R1, how many OSPF routes exist? So let's go to P1R1. Let's go right here. Let's do a do show IP route. And we can see that we have these 4 routes, which is 1, 2, 3, 4. We have another one right here, which is 5. And we have another one right here, which is 6. So we have 6 OSPF routes. Let's make sure that is correct. How many routes exist? Right here it says 6 OSPF routes exist. We just confirmed that with our output, so perfect. It says, what is the administrative distance of OSPF routes? Well, if we look right here, this first number within each of these OSPF routes is 110. And we know that 110 is the AD or administrative distance for OSPF. So let's just confirm that. Right here, it says the AD of OSPF is 110, which is what we just verified. And it says on P1R1, verify the new AD, which we're looking at it right here. It has an AD of 110. So we just verified it. So perfect. So let's go ahead and go to task 2. It says use the IP OSPF command. It says on P1R1, display OSPF process information. Use the output to answer the following questions. Okay, let's go to P1R1. Let's do a do show IP OSPF. Okay, this is the output that it wants. it says, what is the router ID? So if we look right here, we can see that our router ID is right here, and that is 192.168.1.1. So let's just write these down on our iPad. So for A, we have 192.168.1.1. And what we'll do is we'll confirm all of these answers as soon as we get down to task 3. So it says right here for B, why does the router select this router ID? Well, first is going to, you can really configure a router ID, but if a router ID is not configured, it's going to use the loopback. If a loopback interface is configured, it's going to use that interface. And if a loopback interface is not configured, then it's going to use an interface that is in the upstate. So any interface that's in the upstate that has I think it's the highest IP address, it'll select that. So I selected this router ID because it is a loopback interface. And usually loopback interfaces don't change, so that's why I was going to choose the loopback interface first. You really should configure a router ID so you know that that IP address that's configured for the router ID is not going to change. With OSPF, it has to have a consistent router ID to identify the router. If that changes, it could cause problems with OSPF neighborships. So we just need to be aware of that. So it says right here for C, how many times has OSPF executed shortest path first SPF? So we can see right here that SPF algorithm executed 10 times. So let's go ahead and write that down. It said 10 times. Okay, for D, it says how many interfaces are in area 0. So this output should be somewhere in here. Yep, right here. It says number of interfaces in this area is 3. So let's write that down. And let's go ahead and go to E. E is asking how many areas does this router participate in? And as we can see, we can just see that it has one area, which is the backbone area of area 0. So it doesn't have any other areas. So how many areas does this router participate in? It participates in one area. So we have our answers right here. Let's confirm these answers within Boson. So right here for A, we see that our router ID is 192.168.1.1, which is what we have. It says the router selected the 192.168.1.1 as the router ID because this address is the loopback IP address on the router. OSPF prefers a stable router ID. If loopback interfaces are present, OSPF will not consider other interface types. So that's what we explained earlier. It chose it because it is a loopback IP address, and OSPF prefers a stable router ID so it can keep its neighborships up. So perfect. For C, it says according to the sample output above, it said that it executed 7 times, but it says your output may be slightly different, and ours is. We had 10, and we can confirm that down here in our output on our device. So it executed 10 times on this device. Okay. For D, it says 3 interfaces are in OSPF 1, which is what we have right there. So perfect. And it says this router participates in one area, which is what we have right there. So perfect. Alrighty. Not too bad of questions at all within Boson for this particular lab. Maybe it'll get harder. Maybe I spoke too fast. But for task 3, it says use the show IP OSPF neighbor command. So it says right here on P1R1, display OSPF neighbor information. Use this output to answer the questions in the task. So let's go over to P1R1. We're already on it. Put my pencil down, my iPad down so I can see the console. Let's do a do show IP OSPF neighbor. Okay. So it says how many neighbors does P1R1 have? And we can see that it has 2 neighbors, which is P1R2, and it also has a neighbor with this is P1, this is P2R1 right here, and this right here is P1R2. So this connection right here is P1R2, which is 192.168.1.17 going up here, And it has this connection, which is 192.168.2.1, which is this router's loopback interface right here, which is P2R1. So right here. Okay. All right. So how many neighbors? Let's write this down in the iPad. It has 2 neighbors. So for A, it has 2 neighbors. Okay. What does the full state indicate? The full state indicates that they both of these routers share the same LSDB, which is what we want. So full state means these routers have the same LSDB, and LSDB stands for link state database. So perfect. All right, it says which router on the fast Ethernet 00 interface is the designated router. So we can see right here that this fast Ethernet 00 connection is what it's talking about, and it's asking which neighbor is the designated router. So we can see that P2R1 is the designated router. So let's put P2R1 is our designated router. And it says, why is there no DR or BDR on P1's R1's serial 0 interface? And the reason why it's not the reason why it's not a DR or BDR on this connection is because it's a serial connection. So it's a point-to-point connection. So with that being said, it can only be a point-to-point connection. And it's basically this connection is just between these 2 routers. When you're using a serial interface connection, it can only be 1 point on one end and 1 point on the other end. It can't be like an Ethernet connection where you can have, many different routers connected. Ethernet and serial are 2 different technologies. And with serial, you can only have a point-to-point connection. So there's no need to elect a DR or BDR in that case. Basically, the DR and BDR are used to, they're used to, basically, it'll elect a DR and a BDR. And the DR and the BDR be in charge, the DR would be in charge of advertising the LSDB to all of the other routers. So a full adjacency doesn't have to be between all of the routers. So let me just write down, why is there no DR or BDR on P1 R1s? Okay, I'm gonna say it because it is a serial point-to-point connection. Perfect. Alrighty, so let's go ahead and put our iPad up now, and we're going to look at the output that Boson gives us, and hopefully we got everything correct. So let's hit here, and it says P1R1 has 2 OSPF neighbors, and we put 2 right here, so perfect. It says the full state indicates that neighbors have exchanged their LSA databases. Yeah, so they have exchanged LSAs, and they have the same LSDB. So we just put the full state means that routers have the same LSDB. Okay, perfect. It says right here, the 192.168.2.1 neighbor is the fast Ethernet 00 interface, is the DR for the sample output. So that's the loopback interface. Let me zoom in. That's the loopback interface. Zoom in. Of this router, which is 192.168.2.1, and it is P2R1. So P2R1, that's what we have right here. So perfect. Let me zoom in just to make sure that we got that IP address. And you guys can see that to make sure that it is correct. So P2R1, 192.168.2.1. Perfect. Zoom back out. Kind of scoop this over. Okay, go back up to our topology. Okay, and for D, it says there is no DR or BDR for P1R1 serial 0 interface because DR and BDR elections do not take place on serial point-to-point networks. So I put that right here. I said because it is a serial point-to-point connection. Perfect. So let's go ahead and go to task 4. It says use the show IP OSPF database command. So it says on P1R1 display OSPF link state database. Use this output to answer the questions in the task. So first, let's put down the iPad so we can see our console a little bit better. And let's do a do show IP OSPF. And let's do a database. Okay. So it says how many link state advertisement LSA types are shown. So we can see that there are 2 LSAs shown. We can see that we have our leak state, router leak states. So we can see that these are LSA type 0. And then we have our network link state LSAs, which are LSA type 2. So we have 2. Let's go ahead and write that down. We have 2 LSA types. Okay. For B is asking what type of router generates a router LSA. That is a good question. And I believe a router generates a router LSA. Well, we can look and see which routers. So we have this router, which is P1R1. We have this router, which is P1R2. We have this router, which is P1R3. We have this router, which is P2R1. We have this router, which is P2R2. And we have this router, which is P2R3. So all of our routers, it should be all routers generate router LSA. So we're going to put that. We're going to say all routers with OSPF enabled. I should put all OSPF routers. All OSPF routers generate router link LSAs. Router link LSA. Let's go over to C now, and it says what type of router generates a network link LSA. So we can see right here that P1R1 presented a network LSA. 192.168.1.49. Where is that located at? 192.168.1.49. It looks like that is P1R2's fast Ethernet's connection that generated that LSA. And we can see right here that 192.168.2.50. So that 2.50 would be this link right here that generated a network LSA. So I'm not sure which routers. Let's see what it's going to say for the output on Boson. I'm not sure, so I don't want to answer that one. So it says 2 LSA types are shown. Let me pull up my iPad. We put 2 down, 2 LSA types. Okay, so right here it specifies. It says an internal router generates a router LSA, and a designated router generates a network LSA. So that's good information to know. So an internal router generates a router LSA. So we got this one wrong. I put all OSPF routers generate router LSAs, which is incorrect. It says an internal router generates a router LSA. So I learned something new there. And right here it says a designated router generates a network LSA. So this was a really good question. And like I thought I was going to trip up after I said that these questions were easy in Boson. It turns out they're not so easy. I got those 2 wrong. So let's go ahead and move on to task 5. Task 5, it says use the show IP OSPF interface command. Okay, so let's go ahead and put down our iPad. And let's go ahead and let's do a show do show IP OSPF interface. Okay. So it says how many interfaces, let's highlight this, how many interfaces are configured for OSPF. So if we look up here, we can see that this is one interface. So fast Ethernet 00, that's 1. We have the loopback interface, which is 2, and we have the serial interface, which is 3. So we have 3 interfaces configured for OSPF. So let's write that down. Let's write that down. 3. Okay. It says, what is the router ID used for every interface? So we can see that our router ID is right here, and that is 192.168.1.1. That is going to be used on each and every interface. So let's go ahead and write that down. 192.168.1.1 is our router ID. It says how often, for C, it says how often are hellos sent out. So if we look right here in the output, it should be somewhere in here. Yep, right there. It says we are sending hellos for OSPF every 10 seconds. So we know that our hellos are being sent every 10 seconds. And our dead time is going to be 3 times our hello, 4 times our hello interval. No, 3 times our hello interval. No, 4 times. Because, yeah, 10 times 4 is 40. Yeah, so 4 times our hello interval. So we get 40 for that. But it says right here for the next question, D, it says, what is P1's R1's fast Ethernet 00's address? So if we go to P1R1's fast Ethernet 00, we can see its IP address, or its address is 10.10.100.1. So let's go ahead and write that now. You can see that it's 10.10.100.1. No, 10.100.100.1. Sorry about that. 10.100.100.1. Okay. It says right here, it says, what area is the fast Ethernet 00 interface in? Well, we can see that the area is area 0. So let's go ahead and put that. Area 0 for E. Area 0. Let's go to F. It says, what is the cost for using the fast Ethernet 00 interface? So we can see our cost right here. It has a cost of 1. So let's go ahead and write that down. A cost of 1. Let's go ahead and move on to G. G is asking, what is the priority number for the fast Ethernet 00 interface? So our priority right here, it is also 1. So let's put our priority is 1. Okay, let's go to H. It says, what is the IP address of the DR? So our designated router, which is right here, has a IP address of 192.168.2.1. So 192.168.2.1. Let's go ahead and move on to I. I is asking, what is the interface IP address of the DR? So the interface IP address is right here, which is 10.100.100.2. So 10.100.100.2. Okay, let's go ahead and move on to J. It's saying, what is the IP address of the BDR? So we can see right below that, we have the IP address of the BDR, which is 192.168.1.1. Okay, so 192.168.1.1. Let's go ahead and move on to K. K is asking, what is the interface IP address of the BDR? We can see right here, the interface ID is 10.100.100.1. So let's do 10.100.100.1. Let's move on to L. L is asking, right here, it says, what is P1's R1's serial 00 IP address? So if we go down here to the serial 00 IP address, it is 192.168.1.33. So 192.168.1.33. Let's move on to M. M is asking, what area is the P1R1 serial 00's interface in? Well, we can see it's in area 0 right here. It says area 0. So we know that that is in area 0. And last but not least, we have N. It says, what is the cost for using the serial 00 interface? And the cost For the serial 00 interface, 64. So let's put a cost of 64 for the serial 00 interface, which is a lot more of a cost than our fast Ethernet connection. So we can see that our fast Ethernet connection is a broadcast, but our serial network type is point to point. And that's because what I explained earlier. When you're using Ethernet, you're on a broadcast domain, but when you're using serial connections, that is a point to point connection. So you cannot, it's just basically two endpoints on that connection. So let's just check our answers right quick. And hopefully we got everything correct on this one, because I kind of messed up on the one before. But the first answer, it says we have 3 interfaces configured on OSPF, so that is correct. It says the router ID for every interface is 192.168.1.1, which is what we have. It says hellos are sent out every 10 seconds, which is what we have. It says the P1's R1's fast Ethernet 00 address is 10.100.100.1, which is what we have. For E, it's asking the fast Ethernet 00 interface is in area 0, which is what we have. It says the cost for using the fast Ethernet 00 interface is 1, which is what we have. It says the priority number for the fast Ethernet 00 interface is 1, which is what we have. It says the IP address of the DR is 192.168.2.1, which is what we have right there for H. For I, is asking the interface IP address of the DR, which is 10.100.100.2, which is what we have for I. The IP address of the BDR is 192.168.1.1, which is what we have for J. For K, it is asking the IP address of the BDR, which is 10.100.100.1, which is what we have for K. L, it was asking, it says, what is P1 serial 00's IP address? And that is 192.168.1.33, which is what we have for L. Let's move on. It says P1's R1 serial 00 interface is in area 0. So we have that down there for M. And lastly, we have N. It says the cost for using the serial 00 interface is 64, and we have that down there at N. So let's go ahead and hit grade, and hopefully we got everything correct, which we did. So thank you guys for watching this one. I'll see you in the next one.